Hi students, in this video I'll be going through the 2012 O-Level Additional Mathematics, paper 2, question 3. So let's read the question. The equation of a curve is y equals to a times e to the power of 2x plus b times e to the power of negative x, where a and b are constants. The point P04 lies on the curve, and the gradient of the tangent to the curve at P is negative 1. Find the value of A and of B. Alright, so over here we have two unknowns to be found. Okay, so if you recall what I've mentioned in the past, whenever you have two unknowns inside a question that you want to find, right, what should come to your mind would be simultaneous equation. Because when you have two unknowns, then if you are able to obtain two equations involving the two unknowns, then you can form two simultaneous equations and solve them. Alright, so for this question, the first thing that comes to mind is how are you able to get the two equations from? Okay, do we have enough information given in the question to form the two equations? Right, so the equation of the curve is y equals to a. Okay, so let's write out first. Y equals to a times e to the power of 2x plus b times e to the power of negative x. Right, the first piece of info that is given to us is that the point P04, right, lies on the curve. Okay, so this means that the curve passes through 0, 4, and it also means that for this equation, when x equals to 0, y is equals to 4. And this will actually enable us to find the first equation. All right, so that's basically what we are going to do. Right, so at P04, so at P04, okay, when x equals to 0, y is equals to 4. Okay, so I'm going to substitute a 0 inside the x and then equate it to 4, right? Okay, so a times e to the power of 2 times 0 plus b times e to the power of negative 0 is going to be equals to 4. Right, so we know that anything to the power of 0 is 1, right? So e to the power of 2 times 0 is 0, right? So a times e to the power of 0 is going to just give me a, right? Then the same thing will happen for here. E to the power of negative 0 is the same as e to the power of 0. Okay, so b times e to the power of 0 will be again b, right? So the first equation is actually very simple. It will be a plus b equals to 4. Okay, so this will be equation 1 already. Okay, so I have my first equation. So now my next question is, how can I obtain my second equation? Is there any info given to us now? So you'll find that actually there's info given to us. Okay, so they say that the gradient of the tangent, okay, to the curve at P, okay, at the same point P, whereby x is equal to 0, is negative 1. Okay, so we know that the gradient of the tangent, okay, can be found by the function for the gradient of tangent is actually dy dx, right? Okay, so basically what they mean here is that when x equals to 0, okay, because it's also at the point P, dy dx will be equals to negative 1. Okay, so what we need to do now is to find dy dx, and then we will be able to form our second equation already. Okay, so let's differentiate this exponential function. Okay, so exponential functions are extremely easy to differentiate. Okay, so the first term, a times e to the power of 2x, when you differentiate any exponential function, it basically just remains the same. Okay, all you need to do is to differentiate the power. So for e to the power of 2x, you differentiate the power 2x, you just get a 2, right? So you just multiply the 2, all right? Then plus b times e to the power of negative x, same thing, just write out the whole thing again. Differentiate the power negative x, you will get negative 1, and there you go, okay? So just tidy up a bit. So dy dx will be equals to 2a times e to the power of 2x minus b times negative 1 becomes minus b times e to the power of negative x. So here is your dy dx ready. Okay, so remember at point P04, dy dx is negative 1. So this is the dy dx value. So when x equals to 0, okay, because at the point P04, so this one actually we can add in at P04, okay, when x equals to 0, dy over dx equals to negative 1. right? So same thing, we're going to sub x equals 0 inside the x value for the x value for this dy dx, and then equate it to -1. Right, so let's do that. So 2a e to the power of 2 times 0 minus b e to the power of -0 equals to -1. Okay, so same thing. E to the power of 2 times 0 is e to the power of 0, which will give you 1. So down here we just get 2a minus b. Okay, e to the power of -0 is again 1, right? Equals to -1. So over here we have our second equation, right? Okay, so to solve these two equations is very easy. We can just use the elimination method. Over here we have b, over here we have -b. So we can just add equations 1 and 2. So 1 plus 2. Okay, so left side plus left side. So a plus b. Okay, plus 2a minus b. Okay, right side plus right side. So 4 plus -1. Okay, so this will give us 3a equals to 3. So a will be equals to 1. Okay, then we just take a equals to 1 and maybe sub it inside equation 1. Okay, so substitute a equal to 1 into equation 1. So we have 1 plus b equals to 4. So b will be equals to 3. Okay, so there you have it. A is 1 and b equals to 3. Okay, so I've actually put in these values and type out the equation of the graph right in decimals, and then I pop it over here on the right side. Okay, so you can see when a is 1, then the equation of curve becomes y equals to e to the power of 2x, and b is 3 plus 3 times e to the power of -x. Okay, so I've drawn out the graph and it looks like this. Okay, so you can see actually quite clearly. Okay, this graph actually passes through the point 0, 4, okay, which is on the y-axis. And at this point 0, 4, you can see that the gradient of the tangent is indeed a negative gradient, okay? Because as stated in the question, the gradient is actually -1. Right, so such a question like this, not too difficult. It's a 4-mark question. Okay, so always remember whenever you have two unknowns, then you think of forming two simultaneous equations, then you can solve it. All right.